Yeah, welcome once again. So we want to solve the second question. And the question is this: 9 raised to the power 2x minus 1 multiplied by 3 raised to the power 3x minus 1 is equal to 27 raised to the power x plus 3. So the first thing we have to do here is to check each of these numbers. Is it possible for us to express them on the basis of the same base? And to be able to pick the base we are going to use is to look at the smallest base which exists here. And we can see that the smallest base we have on the board here is what? Is 3. Then the next question I should ask myself is it possible to express 9 on the base of 3? That is, I want to rewrite 9 having the base of 3. That is, I want my 9 to be a number having 3 as its base. 27 as well, is it possible to re-express this number in such a way that its base is 3 raised to power something? So that is the first way of reasoning. So having done that, we now move to the next step of the solution, which means that what? It is very possible to express 9 in index form having 3 as its base. If we do that, 9 becomes 3 raised to power 2. So 9 here becomes 3 raised to power 2, and the power we have earlier will be what? Subjected to a bracket, or we'll put it inside a bracket. That is 2x minus 1. Now multiplied by, so this one is already in the expected base, so no need to worry ourselves. So we just copy it the way it is. So multiplied by 3 raised to power 3x minus 1 is equal to express 27 in index form having the base of 3 is to call it 3 raised to power 3, because it's only when 3 repeats itself 3 times that it's going to produce the value of 27. So that becomes 3 raised to power 3 into x plus what? X plus 3. Then the next thing is you're having multiplication sign. And remember what usually happens whenever we come across multiplication between two different index. So what we do there is, let's check those bases, the bases we have in there. Are the bases the same thing? So if the bases are the same thing, we know from the first rule that what? One of the two bases is going to be chosen, or one of the two bases is going to be selected. And once that is done, multiplication will no longer function as multiplication, but rather function as what? As addition. And like I used to say it, it's going to function as addition to what? Addition to the powers which we have. So that's going to become 2 into 2x minus 1 plus 3x minus 1, then equal to 3 raised to power 3 into x plus 3. And with this, we can see that in this part of the equation and in this part of the equation, we have some common thing. That common thing we have is the base of 3. And automatically, these 3 cancel these 3. When we've done that, what we are now left with is 2 into 2x minus 1 plus 3x minus 1 is equal to 3 into x plus what? X plus 3. Then the rest is to solve it as usual. But solving it first requires opening this bracket. So 2 times 2x here gives 4x. 2 times minus 1 minus 2 plus 3x minus 1, which I have here, is equal to, so we also ensure to open this bracket here. 3 times x here gives what? 3x, and 3 times plus 3, that gives plus what? Plus 9. Then the next phase of our solution requires what? A form of rearrangement, or what we can call what? The collection of like terms. And what we mean by collection of like terms is that anything variables will be packed in one part of the equation, while anything constant will also be what? Taken to the other side of the equation. So to do that means I'm going to take 4x. Any other thing with x is this 3x, but here it's going to be plus 3x. Do we have anything still having x? So this is the next one. But because this one has a cost to travel, to move over this equation sign, definitely it must change its sign from being a positive number to what? To a negative number. So 3x here becomes minus 3x is equal to, we also ensure that what? All the constants, that is all the numbers without x, I gather the one part in the other part of the equation or the other side of the equation. But the first one, since we want everything to come here, so the first one I have here is what I'm going to write first. So I'm going to write my line. This is a constant, that's number without x. It also needs to move to come and join this line. But in the process of it moving here, it has to cross this equation sign. And anything that crosses equation sign must what? Have its sign change. So since it's having minus 2 here, it changes to what? Plus 2. Likewise, this last number here, minus 1, when it also crosses over to come and join this line, it also becomes what? Plus 1. So 4x plus 3x minus 3x, we can see that this week 3x minus 3x is 0. So we are left with 4x here is equal to 9 plus 2 is 11 plus 1, that gives 12. Then the rest for us to get x now is to do what? To remove the 4 here. And the question I should ask myself is, what is the role of this 4 here? 4 is acting as coefficient to x. And removal of anything coefficient is to do what? To divide both sides by such what? A coefficient. So in this case, I'm going to divide both sides by 4. I'm going to divide both sides by 4. So when that is done, 4 in 4 here is 1, 4 in 12 gives 3. So therefore, we can conclude that what? The value of x is equal to 3.